Hi, welcome to today's lesson on square roots. I have a little assistant in the back there, you might have noticed. Let's start out with some vocabulary. Square root. What is a square root? Okay. A square root is a number that when, get my letters together, multiplied times itself gives the given number. Gives the given. Interesting way to say it. But let's just look at what I'm talking about. So the square root of 9. So what number times itself would give us 9? Well, there are actually two answers for this. Okay, because 3, I hope everyone knows that one, 3, because 3 times 3 equals 9, but there's another answer, okay? There's another number that when you multiply it times itself gives you positive 9, and that would be negative 3. So negative 3 times negative 3, put a little parentheses around these for a second, also gives us positive 9, okay? So those are both square roots of the number 9, positive 9. Okay. Now, we're going to talk about square roots that are not nice and neat like 9, and we have a name for what that is. Okay. 9 is called a perfect square. And a perfect square is when the square, and I'm going to abbreviate that SQ, square root is a whole number. That's not even necessarily a whole number. It's not, it's, because it could be a fraction, it could even be a decimal, okay? Is rational, not really an important word in this case, but it's meaning it's either a whole number or a repeating or terminating, meaning it ends, decimal. Now this can be a fraction when you write it, like 1/3 would be a repeating decimal. 1/2 would be a terminating decimal because it'd just be 0.5. Those are all perfect squares. Okay? So what we're looking for is something that you can do. If you type it into a calculator, you get an answer. And it's either something that's like, oh, it's 0.33333 because it was a third, or it's 0.25 because it was 1/4, or something of that nature. If you type in 8 into your calculator and hit the square root button, you're going to get a crazy, crazy long decimal. And the only reason that it stops at the end of the calculator is because that's the end of the calculator. If you had a longer calculator, you would have more digits. And in truth, that number never ends and it never repeats. It's an irrational number and it just goes on. Okay? All right. I got one more vocabulary, but I don't have any space, so I'm going to erase space. Give myself some room to write. Okay, and the word is radical. Now, this is not surfers on the beach going, dude, it's radical. What this is this is the symbol for square root. That's a radical. Because the reason we need this word is because, well, I mean, I guess we could just say the square root sign all the time, but we don't. And your other teachers will probably almost certainly use the word radical, even including simplifying the radical. But we actually use the radical. The radical works like a parentheses, because if there's something for you to do mathematically under the radical, we're going to do that math under the radical, and then we will apply it. In truth, and here it is, this is one of my favorite things to teach students. In truth, that symbol is actually an exponent. It works a lot like a parentheses, but it's really an exponent. What exponent is it? 1/2. Okay, this comes right after we've done a video on multiplying with exponents, dividing with exponents, and then zero and negative exponents. And now I'm telling you, you know what? That's an exponent too. It's the exponent 1/2. When you get into other math classes and you start seeing cube roots, that's a fraction of 1/3, and so on. Okay, but it is actually it is actually an exponent. Technically, that's where it should be done, but because it's over a whole thing, that whole thing is like it's inside of a parentheses. So let's start with the simple. Like I said, we did the square root of 9, which was 3 or -3. But what if we don't know it? What is the square root of 35? Okay, now, I honestly don't know it. I really don't. In fact, nobody knows it. They could figure it out. Okay, there's probably human calculators out there that can do it. But in truth, we don't actually really know it without a calculator. We can come really close to estimating it, but we don't know it. And in fact, for purposes of what we're going to be doing in this, we don't even need to know it. What we need to know is approximately what it is. And how do we do that? We bookend it with 2 perfect squares. 25 is a perfect square because it is 5 times 5. Well, the next one up would be 36. That is 6 times 6. 35 falls right in between them. In fact, it's just a little less than 36. So if I had to guess, I would say it's a little less than 6. I'd say it's probably 5.9. And I'm sure if you type into a calculator, you'll see that it is 5.9 something. So when we're asked what is the square root of 35, we put that it is between 5 and 6. It's not that we couldn't know it and we couldn't do it with a calculator, but there's no math for us to do. There is no way that I can there's nothing for me to do except start trial and error of a million possible, okay, well, I know it's pretty close to 36, so let's start at 5.9. Well, 5.9 times 5.9 gets us this. Well, that's pretty close to 35, so let's make it 5.91 and see what that does. But even then, no matter how many times I do that, I'm only going to get close because the actual square root is a non-terminating, non-repeating decimal that goes on forever. Okay? So the best that we can really hope to do when presented with a non-perfect square under a square root sign is estimate it, approximate it. What 2 perfect squares is it between? And therefore, what 2 square roots is it between? It's between 5 and 6. Great, if I have to estimate it, it's closer to 6. If they ask me which is it closest to, I'm just going to say 6. Those are really the only things that I'm going to do when I see this. And just to give you one more word, this is an irrational number. It's not terminating, it's not repeating, it's not whole, it's none of those things. It's irrational. Okay? So I don't know why they get excited if you know what an irrational number is and if this is or isn't an irrational number, but they really do. Whenever you take the square root of a non-perfect square, you get an irrational number. If you take the square root of a perfect square, then you get a rational number. Okay? So either you have 2 possibilities. Either the answer is going to be a whole number, or it's going to be between 2 whole numbers. That's all they're ever going to ask you for, at least at this stage. Okay? Now, remember I said that it works like a parentheses. So I'm going to ask you to simplify. Nice and easy one. The square root of 5 minus 1. So all of this is under the radical. That's a term you may hear, under the radical. Okay, under the square root sign, so under the radical. Okay, but again, we are going to do that first. And then we know, hey, square root of 4, we know that's 2. Now, I'm saying 2 and I'm not saying -2 because if I wanted if I want the negative root, then I would put the negative sign in front of the square root sign, in front of the radical, because of how we would say the question. I would ask you, what is the negative square root of 4? We know there's two. We know there's a positive one and a negative one. Which one? Here I'm specifically asking you for the negative root. So if the negative sign is in front of the radical, then it is specifically asking you for the negative root. We know there's a positive and a negative. We're specifically asking you for the negative one. Why would we want that? Really, I don't know. Have a good answer for that. But that's what the negative sign in front means. Okay. So, with that being said, so if I give you this one, the square, this is, and it's how we read it from left to right. This is the negative square root of 25. Negative 5. How is that? So now I'm going to say, how is that differ? Maybe how does that differ? Say, how does that differ from this? So let's just say it out loud. This is the negative square root of 25. We know there's a positive square root and a negative square root. We're looking for the negative. This one is the square root of negative 25. Okay? And I'm going to be very specific on this one because of a friend of mine, that there is no real number for a negative square root. Well, what does that exactly mean to us? That means no answer. No answer. And you're actually going to see this in later math classes where it's actually going to matter, where the answer being no answer is actually important. Specifically, the first one I know you're going to encounter is when you're going to have something called a parabola, and you're going to have, which looks like this, and you're going to be asked, when does it hit the x-axis? So this is the y, and you'll go, it's here and it's here. What would this mean when there's no answer? It would mean it looks like this, that it never comes down to the x. So it actually has an application where it actually means something, okay? So knowing that it's no answer is not like, well, and then we just stop because it's not important. It's like, no, it actually means something, okay? Maybe even more importantly, that there's a parabola that looks like this, and that's sort of like, you like threw the object up, but it didn't get high enough to hit this line, okay, for whatever reason, okay? That one also has no answer. The answer is that there is no answer. It never never touches the x-axis, therefore, and it is determined because you'll find something where there's a square root, and the square root is going to be the square root of a negative. And for us, we just go, nope, can't do that. Don't bother. Okay, no real number will work for that. There's no number on our number line that will work, so we're done. The answer is that there is no answer. Okay? So, got one more quick example here because I want to show you, again, we're going to simplify. Even when we can solve it, we still sometimes will be asked to simplify it. The fraction 4/9. And you notice I drew it like extra long because I want us to understand that this square root sign is over the whole fraction, because we can actually break it up into two separate square root signs. And that sometimes matters if one of them is a perfect square and one of them isn't. And for later, this is again stuff you'll do later, but this is I'm laying the groundwork here. For us, we can do that because the square root of 4 is 2, the square root of 9 is 3. These are all, because this whole thing is just a mix of, You can see the whole thing is a perfect square, or it's two individual perfect squares that turns into this fraction of 2/3, which is a repeating decimal, therefore it is a perfect square. Okay, so you can take that and break it up, okay, and if you later on you will encounter ones where like one of them is a perfect square and one of them isn't. Like I'll give you an example, like that. I don't know what the square root of 3 is, but I do know what the square root of 4 is. So I would leave square root of 3 as square root of 3, and I would do the square root of 2. By the way, that was the last thing I wanted to mention. If you get an answer along the way where you're doing a square root and you get the square root of 3, the square root of 35 like we saw earlier, the square root of something that's not a perfect square, you can usually just say that's my answer, okay? Because that's exact, that is the answer. And even though I don't know what the square root of 35 is exactly, if you use the square root of 35 and tell me it's the square root of 35, then you're being exact in your answer. And if you use a calculator, it'll give you a pretty good approximation. It's not perfect because, again, it doesn't go on forever and it eventually has to stop because of the length of the calculator. But that is an acceptable answer. Square root of 3/2 is a perfectly legitimate, correct answer. And you wouldn't even want to turn that into, because it'd be a long, crazy decimal, and you usually don't want a decimal in a fraction. Square root is okay. You're not allowed to have them in the denominator, and you'll see that later on as well. We won't encounter that here. When you get into your next grade level, they may be ones where they have the square root sign in the denominator, and then you'll have to do something called rationalizing the denominator. I don't want to go into that, obviously, because that is a whole lesson unto itself, and you will see that when you're in high school somewhere. All right? So that is square roots, which I will, just to bring it all the way back around, remember, is the fractional exponent 1/2. Okay, so I hope that helps. I'll see you in class or in office.